Hi, welcome to the Calculus 1 lecture series. And we are in our lecture number 29. And for the unit number 4, integrals. And in fact, this will be the last section for this unit. And we are going to introduce our first integration kind of the skill. We call this the substitution rules here, okay? And now let's go ahead, take a look, go to our lecture notes, and we can start to work on that. Okay, so let's take a look. What, is the substitution rule? Okay, so now let's kind of the refresh or like a review what we learned before, right? So like when we talk about the antiderivative in our previous unit, we said, for example, we said xn dx, then the antiderivative will be the n plus 1 x the n plus 1 plus c. So of course, we assume the n is not equal to the negative ones, right? Then we'll say the 1 over x dx, this will be the natural log x plus c, something like that. And then, for example, if I have cosine x dx, and we say this will be the sine x plus c, and the right? So this is what we learn from the antiderivative. And so we will see here, for those formula here, we all have what? The single variable x, right? So now we are in the situation, how about it is not like the x here. So for examples here, right? So for example, so if I say, well, I have a 3x plus 2 to the 10th power dx. So in order to take the integration of this problem, then you say, hey, here, you say, hey, here, this is the 10th power. It seems, well, maybe I can use the power rule as long as, but the problem here is inside here is not just the x here. If I can just apply the power rule, that would be pretty easy, right? Will just be the 3x plus 2 to the 11 powers over 10 plus 1 is 11. But the problem here is the x and here is the 3x plus 2. And so I cannot apply what I learned. Those I call these fundamental formulas, right? Or the parent, kind of like the parent's function concept, right? So I cannot apply to that. So now, what I need to do here, then you can say, hey, I can just FOIL it, right? So yes, you can FOIL it. You can do the 3x plus 2 to the 10th power, then you can FOIL it. And then it might take a while, probably an hour, when you get all those terms out, right? Then you can apply to each one. That's too much trouble here, right? So that's what we are coming to this we call it is the substitution rule. So what is the substitution rules here? So we said, if you have a functions here, right? So we say, let's say the u is equal to a function gx, and this gx is a differentiable, right? It's a differentiable, and whose range is an interval I, and the f is continuous. And the f is continuous on these intervals. Then we say here, if you want to take the integration, the f of what? Gx, right? Then the g prime x dx is equal to, so f of the u and the du's, right? So Then we said here the reason why the du, because u is gx, is g prime x dx here. So in here, so as you can see, if I use this way here, right? So now I change to my basic, just the one variable, the u, just like the x here. Then I'd be able to apply my, kind of my fundamental, those basic, the integration antiderivative formulas here. So that's why we call it a substitution. So just like we did for this, for these examples here, right? The 3x plus 2, right? So now this f of a function is what? Is a 10 to the, is the exponents function. Then the gx here, right? Gx, if you say the u is gx, then the whole thing's here, right? So you will become what? You will become the u to the 10th power. Then the dx here, right? So then you will say the gx here, this is 3x plus 2, right? Then you say it's u, then the dx, so the du will be equal to what? 3dx. So you will say 3, so the dx here, right? So then you can say the dx is equal to du over 3. So you will have a du over 3. Then if you move the 3 out, so this will be the u to the 10th du. See now, if you take a look, now this one here is only u du. So it's a very, then I can apply my fundamental, the formula we learned from the antiderivatives here. All right. So to me, for the substitution rule, it's kind of like a detective game. So you kind of see which one you need to assign to be a u function. So you can simplify it to an existing antiderivative formula, which you are familiar with. All right. So now let's take a look at that. Let's start with this one here. So let's say the u, this is f of x cubed plus 3x here, the x squared plus 1. So in here, you see first things here, right? So you see this is a power, right? So I hope I can use the power rule. But then inside the function is kind of it's kind of complicated. So if you take a look at this function, x squared plus 3x, and then you compare to this function, the remaining function is x squared plus 1. So the x squared plus 3x, you just eyeball that, you take a look at the first derivative, x cubed. So you have the opportunity to become here. All right. So now you say, okay, maybe I will assign the u is equal to what is x cubed plus 3x, right? So if u is x cubed plus 3x, this is what? This is your yellow terms here, correct? So it's u, all right? And then I need to match all the remainings, right? So in here, okay? So you say here, then I can change that my u is this yellow term. So I can say it's u to the 4th. Wow, that's pretty good. All right, but I still have the remaining this, I still have the remaining this light pink terms, right? So let's see what I can do. So if EU is equal to this one, so then I take the derivative of both sides. So this is du equal to 3x squared plus 3, then the dx here. All right, so now you see here, this is 3, you factor out the 3, so this is x squared plus 1, the dx. Then you say, oh yeah, this one is exactly the same like the one I highlighted here, and but the problem is I only have trouble, I have this 3 in front. So in order to perfectly match, right, match this purple one, so what you need to do, you can divide by 3 both sides. So you say du over 3 is equal to x squared plus 1, the dx. Now, your right-hand side here, look here, it's perfect match is here, right? So now you can do here, you can say, okay, so this will be du over 3. Correct, right? So this will be du over 3. And then you say, oh, this is a constant. So constant is good. We like the constant. You move the 1/3 out, so this is U4 du. So this is back to our very fundamental, the antiderivative formula. So by power rule, what is the answers here is the 4, what? The 4 plus 1, and the U, the 4 plus 1, right? Plus C. So 4 plus 1 is 5. 3 times 5 is 15. To the what? To the U to the 5th plus C. And because I'm integrating the X, so I need to substitute whatever I assume to be the X, right? So the final answer will be 15. This is X squared, X cubed plus 3X, right? Plus C. So this will be my final answers here. Okay, so be very careful. So that's why I say it's kind of like the, the detective type of the job, right? So you will see which one you want to assign to be a U. Okay, let's take a look at second ones here. Second ones here is X squared sine X cubed. So which one? I know the sine, if you just have a sine X, I can do it, right? So now you said, maybe I need to, get this one as my U. The reason why, because I did spot something. What did I spot? I spotted that if I take the X cubed, take the derivative will give me S squared. So maybe I will have a better chance. All right, so now let's try to take a look here. So let's try to highlight the things that I plan to do, right? So the X is dx associated with this derivative, and my function here is what? My function is sines, right? So now let's take a look. So we'll say U is equal to X what? X cubed, right? Okay, so E is equal to X cubed. Then I can carry this function. So this is a sine U. Okay, now I have this light pink area, right? So I have this light pink area. So if you highlight, so this is my, this function. So here I should have the fourth power. That's my functions here, right? So now I need to match the pink. So du, so the same things here. So you take the derivative. So du is equal to what? 3x squared dx. Then you compare, then you say, oh, my integration is only have x squared dx. They only have this term. I got an extra 3. What can I do? I divided by 3 both sides, right? So du divided by 3 is x squared dx. Right, x squared dx, which match exactly what the remaining terms inside the integration. So what I need to do here, so this will be equal to the du over what? So it will be the, I have the here, it will be the du over 3 here, correct? Okay, so now in here, I can move the 1/3 out. So this is the sine U du. All right, so now we back to our fundamental, the formula. So what is this? What is the integration for sine? For the trig function will give you the integration. The sine is what? Is negative what? It's negative cosine u's, right? And then plus c. Now in here, now you substitute, so you have a negative signs here. So what is the cosine u? What is u? U is x cubed plus c. Right? Okay, so that's why you need to spot where could be the, your u function. Okay, let's start to do some also here. Now let's take a look at this ones here. So this one, hey, the square root, I have the, square root is not bad. Square root is 1/2 power. Then I have this x squared plus 3 inside. So which one probably will give me trouble? And I want to, so I might want to do this one. X squared plus 3 will be my u, because I know when I take the derivative, this is become 2x, have the potential match this x dx. So I will say, okay, so this x dx is the possible will be the derivative of this x squared plus 3. Then where is my function? Hey, this is my function, right? It's a square root. This is my function. Okay, so now let's see here, right? So let's do the same thing. So u is my yellow one is x squared plus 3. All right, now let's see here. Then this will be the integration. So this will be the square roots of the u's, right? So your function carries, right? Your function carry. Okay, now I have this pink part I need to match. So I have a du, this is equal to the 2x dx. Oh, very good, right? I have x dx here, so which match this x dx. But I have this 2, so what I need to do, I divide by 2. So du divided by 2 is x what? X dx. So now you say, okay, x dx, you say perfect, it's a match perfectly, right? Okay, if it's a match perfectly, so now in here, so I will times the du over what? Du over 2, right? Then you can move the 2 in the front, and this is square roots of the u, du. So this is 1/2. What is u square roots? Is 1/2 du. Now what the rule I'm using? Power rule, right? So this will be what? It will be 1/2. So this will be 1/2 plus what? It will be 1/2 plus 1 here, right? On the denominator here. Okay, so this will be 1/2 here. Let's see here. Okay, 1/2. Okay, back. Okay, so it's 1/2 here. So here, okay, so this is 1/2 plus 1. So this is 1/2 plus 1. Okay, let's stop here. Okay, I think the internet kind of turned bad for a few minutes. Okay, so here is 1/2, right? So this is 1/2 plus 1. And this is a new 1/2 plus 1 here, right? Plus c. So here this is 1/2, and this is 3/2, and this is u to the 3/2, and so plus c. So this will be what? 1/3. Now what is u? U is x squared plus 3, right? So this is x squared plus 3. So what does the 3/2 mean? That means you have square roots, and this is 3/2 here, right? And then plus c. So this will be our answers here. Okay, now let's take a look. The next ones here. So the next ones here is involve the boundaries here. So the first thing is still, let's do the same. The square roots is not the issue. So issues here, this is not just a simple x. So this possible will be my what? This possible will be my u. Then what is my function? Is this square root? So it's still the function. Then what is my remaining terms here? So remaining term is dx. Remember, everything in the the integration need to be transformed, right? So now let's see here. We say u is equal to the 2x plus 1. Okay, so then these functions here will be what? The square roots, the function, and the u, right? So it's u to the square roots of the, so the square roots of the u. Now, I said the du, take the derivative of both sides. So it's du, what is the x? 2x take the derivative is 2 times what? Dx. Then you say, oh, okay, I have a dx. And that's what the remaining my term is to have a dx. And then I can just divide by 2. So this is du over 2 is equal to the dx. Yeah, I match. Right? I matched, so now here this will be what? Du over 2. And then you can move the 1/2 out. So this is the square roots of the u, du over 2. Du, just du, right? Okay, so now the things, the other things here we need to be careful is, okay, so this will be du. Now, the other things we need to be careful is the boundaries here. All right, so let's take a look at those boundaries, right? So the boundary is 0 and 1. So be very careful. Those boundary is related to the variable x. There are two ways you can do. One is you can just finish the integration, and finally, when you ready to, after you substitute back to the x, then you can substitute to the 0, 1. Or you can change the boundaries here since you change it to u's, right? So u is equal to, so this is u is equal to what? 2x plus 1, right? So now I need to find the boundary. So when x equal to, when x equal to 0, this is the lower ones, right? So then u is equal to what? 2x plus 1 is equal to what? Is 1, right? So that's why I need to have the boundary here is 1 here, correct? And then now when the x equal to 1, when the x equal to 1, so u is equal to the 2x plus 1. So what is this boundary here? Is 3. So you change the boundary to what? To 1 over 3, right? So be very careful here, right? So this is be careful because your boundary has to change, right? Okay, now I have, this is 1, 2, 3. So this is 1/2. This is mu to the 1/2. So power rule, the 1/2 plus 1, then mu, the 1/2 plus 1. Then you can put the upper lower limit here. So this is 3/2. So this is 1/3 u to the what? 3/2. So you put a 3 and the 1, right? So now this is 1/3 3. So this will be 3 to 3/2. Right? And then minus, you put the lower bound, the 1 to the 3/2. So of course, this number, this is equal to 1, right? 3 to the 3/2 is a what? It's a square root of the 29. So it's 3 of the square root of the 3. All right. So now what is the final answer? Now the final answer will just be square root of the 3 minus what? It's minus 1/3 here, right? So be very careful, because you transfer to the u, so you need to change the upper bound, lower bound. If you don't want to change the upper bound, lower bound for u, that's fine. Then till the end, after you substitute back to the x, then you substitute whatever the x value, you get the same values here. Okay, now let's take a look at this examples here. For this example, is cosine q plus 1 and the sine x here. Okay, so I know, well, cosine x, I know how to find the, the cosine x, I know how to find the antiderivative, right? So and I might want to put the cosine x is like, my use here. Now, what is could be my, my function is this cube, right? Okay, so now the other things here, all the other remainings here, right? So I have this sine x dx here, okay? Sine x dx here. I also have these things remaining layer, right? I have this remaining here. Okay, now let's see, how do I change that? Okay, so I will say u equal to what? Cosine x, right? So we say the u is equal to cosine x. Then the du is equal to what? Negative sine x dx. All right, so in here, let's rewrite it, right? So this is rewrite it. So cosine u equal to cosine x, so this will be u. Then what here? Third power, right? So my function carry over my function u cube, right? So then this one's here, this independent, the plus 1. So I have a u plus 1 here. Right, so this 1 is a constant. So I carry over from here. Okay, now in here, I do have a sine x dx. Wow, that's pretty good, a sine x dx. So the only difference is what? It's a negative, right? So I can change this one. I said negative du is equal to the sine x dx. So that's why the sine x dx, what you can do here, then you will say this one here will be the negative sine x dx, sine. So it's a negative, right? So that means sine x dx is equal to, so here, this will be the negative what? Negative u, correct? Right, so it's a negative, not u, du, I'm sorry, right? So this is du. Okay, so this is a du. Okay, so this is a du. And now I can do what? I can integrate, right? So I have a negative sign. So I put this negative sign here. Careful, this negative sign, I have a negative sign here. Okay, now you can do, so we can substitute back what is the value, right? So remember, this is the one, half of what? Half of boundaries, right? So pi over 3 and 0. So my function is a cosine, right? So for cosine, when the x equal to 0, what is a cosine? Cosine is 1, right? Okay, then when the x equal to pi over 3, what is the cosine value pi over 3 is 1/2, right? So the 0 pi, I change it to 1 and the what? 1/2, right? I change it to the u. So now I can, so this will be 4u fourths plus what? Plus u. Then what is your, you know, you still have this negative, right? So this is 1/2 and 1. Now we know from the fundamental theory of the calculus, if you have a negative, you know, if you have a negative in front, you can switch this and then you correct the negative. So negative will be positive. So this is mu phi 4 plus mu, right? Then you can switch this to the 1 and the 1/2. Okay, so that means you put the 1 in, so this will be 1 to the 4 plus 1 minus you put a 1/2 in, right? So it's a 4 1/2 to the what? 4th power plus 1/2, right? Okay, so now your answer, final answer is 47/64 here. Okay. All right, so now let's do another one and we can take a break. Okay, so this is x cubed plus 2. So the things caught my eyes here is probably is this power rule. So this probably is my functions here. Okay, and now this probably will be my u here, right? Now I have these remaining terms here. Okay, let's take a look. How do we do it, right? So here, I would say if I set u is equal to x cubed plus 2, all right? And then what I have here, I have a du is equal to the 3x squared, right? Dx. Okay. So 3x squared dx, this dx match this dx, right? Constants doesn't matter. Oh, I have x squared. Well, this is x fifths. What can I do? Well, let's see here. This is right. So I said x squared, right? So how about x fifths? I will say x cubed, right? And this 3, I can, you know, divided by 3 both sides. So d over 3 is x squared dx here. So this x fifths, I can change it to the x cubed times x squared. Then this is x cubed plus 2 to the second dx, right? So let's try to color code that again to see if we can cover all you see. So this is my u. So that's good. This is my functions. And now my du dx is x squared dx is here, right? So this will be x squared dx. This is pretty good. Then the x, I have one extra x3 left. So this x3 is kind of related to this x3. So this one will be here. So I know I can cover that. Okay, so now let's try to write it, right? So this is the u to the what? U to the square, right? So u to the square, x squared dx, this pink one, x squared dx equal to what? Du over what? Du over 3, correct? I still have this yellow one. How do I change it to u? So u is x cubed plus 3. So x cubed is equal to what? U minus 2. Right? So it's u minus 2 du. So let's rearrange a little bit. So I moved 1/3 out. So this is u squared times u minus 2 du. So this is 1/3. So this is u cubed minus 2u squared. Right? So it's u cubed minus 2u squared du. Now everything is back to my fundamental formula. So here, let's take a look. This is 1/3. Now, what is this integration? Is mu to the 4th to the 4 minus 2, 3 mu to the 3rd, right? And the plus c here. Okay, now I can substitute what is my u. So 3 times 4 is what? Is 12. What is u here? X cubed plus 3 plus 2 to the 4th power minus what? Minus, okay, so this is 1/3, right? So 3 times 3, so minus 2 over 9, right? So let's substitute the u3. So it's x3 plus 2 to the what? The 3rd power, and then what? Plus c. All right? So that will be my, substitution for this one. See here. Okay, that's it. Let's take a break here, and when we come back, we can finish the remaining few problems here. All right? Okay. Nice talk to you, and looking forward to talk to you our next videos here. Okay, bye.